seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1.
שיגור הלווין אופק אחד ופריצתו מכבלי כדור הארץ אל היקום הסובב אותנו הוא יום חג לכולנו. זוהי הוכחה נוספת לכך שאיכות ויכולת האנשים המרכיבים את החברה הישראלית היא שתקבע את עתידנו בארצנו. זוהי הוכחה ניצחת לחשיבות העליונה הנודעת לרמת חינוך הנוער, למחקר המדעי ולמערך החינוך הגבוה בישראל. הצלחת מדענינו ליזום, לתרום ולהשקיע מאמץ כה עצום בלימוד מחקר ומימוש המדע לשפת המעשה מביא אותנו לחברה משותפת מכובדת עם מספר מצומצם מאוד של קהיליות מדע ומחקר העוסקות בחלל. אני מלא הערכה לאנשי התעשייה האווירית ושאר התעשיות שלקחו חלק במבצע זה, ושולח להם את ברכת העם כולו על כל תפוצותיו, ומאחל להם ולכל עם ישראל הרחבת פועלנו בכל האופקים לשגשוג ולתפארת מדינת ישראל.
September 19th, 1988. Opek 1, Hebrew for Horizon, the pioneer of the Israeli space program, speeds through the atmosphere into space. Israel Aircraft Industries takes pride in making Israel a member of a very exclusive and unique club. Seeds were already planted years ago. The launching of Shavit 2, July 1961, was a clear indication that Israel was aware of what was known then as the race into space. First to take part in this activity were the research institutions and various universities in Israel. At the same time, various high-tech industries in Israel began assessing the implications of entering into space research. In the forefront was Israel Aircraft Industries, IAI, with annual investments of resources to prepare the basic infrastructure required.
Some 20 years ago, we have identified the fast-growing market of space. And we have decided at that time that investing in that area would bring us in the future a market which is well developed, in which we could do business worldwide. In order to get to this target market, we have invested over the years in our infrastructure and more so in our people to train them and develop them in that area.
A space-oriented directorate, Space Technologies Directorate, is established in IAI. Satellite design production ability is set forth. In 1983, the Israel Space Agency, ISI, was formed within the Ministry of Science and Development.
If Israel wants its high-tech industries to remain competitive in the world of tomorrow, it's absolutely essential for Israel to be actively involved in space technology. This is why the Israeli Space Agency formulated a three-step space program in order to achieve those objectives.
The established Israeli space program includes launching of an experimental satellite, Opek 1, Opek 2, a scientific satellite which will perform a series of experiments, and the development and production of Amos, the Israeli communications satellite. A communication satellite. Why? Today, Israel purchases satellite communication services. The Bezik company is using those services for the transmission of the second TV channel as well as for telephone communications. Forecasting of future requirements indicates an increase in these needs. A domestic communications satellite is therefore an essential need. Its ability to receive radio, television, and telephone transmissions from various sources and to route them to their destinations without the need of many kilometers of ground cables and scarce radio channels makes Amos the least expensive and most efficient solution to our communications requirements.
So for these future needs, we foresee that the use of Amos satellite will create advantages for us and better telecommunication infrastructure in comparison what we are able to provide by using rented satellites from Intelsat or another satellite corporations.
The National Space Program is conducted by the Space Technologies Directorate, part of MBT, a plant of the Electronics Division of IAI. This directorate, officially designated as the main contractor for space utilization purposes in Israel, is making use of other plants of IAI, as well as subcontracting to various other Israeli high-tech companies.
When we started thinking about the space programs in IAI, we started from scratch. We have nothing to rely on. We had no previous experience to count upon. And we didn't know where to go and what to recommend. And I think that today, the perfect launch and the flawless operation of the satellite and the ground station, as you can see here, are the witness of the capability of this division.
Space technology dictates a special class of reliability product assurance, different from that required for the aircraft industries. In space systems, contrary to airborne systems, preventive maintenance after launch is of course impossible. One small malfunction might turn the satellite into a uselessly orbiting piece of metal. The message is loud and clear. Achieving a foothold in space means zero malfunctions. Space environment is harsh and uncompromising and must be fully understood. NASA and other space agencies around the world have developed space standards, lists and requirements. We had to do the same. The final product will face an environment of no gravity, vacuum, radiation, and radical changes of temperatures. When the MBT design and development teams, self-taught in the subject, first undertook the task, they faced an empty slate, lacking the experience and know-how required to design and build satellites. But this inexperience encouraged ingenious thinking, seeking of original solutions, testing and applying new technologies, all leading to a new, revolutionary concept, the mini-satellite. This is Opek 1, once a dream, today a reality. Its height is 2.3 meters, its weight 156 kilograms. While in space, the satellite rotates around its axis at a rate of 1 revolution per second, thereby acquiring its directional stability in space and enabling reception of solar energy by its body-mounted solar panels. The future Opek 2 will carry sophisticated control systems and will be Earth-wise stabilized in space. Such systems will be carried by Amos, our blue and white communication satellite as well. This is a full-scale model of Amos. Its height is 2.3 meters, its width 1.5 meters. Its solar panels expand to 12 meters and its weight is 1,200 kilograms. The advanced technology features will enable Amos to satisfy today most of Israel's communications requirements: television, telephone, and data transmission. Amos will be capable of simultaneous transmissions of 12 TV stations or 16,000 telephone calls.
We believe at IAI that there exists a marketing window for very small satellites, what I would call mini satellites. And I do expect that in the next century, and even before, there will exist mini satellites for a lot of very small countries. Like today, there exists a large market for mini computers.
Satellite subsystems also have a marketing potential. Using today's technology, their low cost and weight makes them attractive to other satellite-producing companies. The testing facility. Here, the predicted performance is verified in space-simulated conditions. On the testing pod, the horizon detector. Space conditions are simulated and shown by the computer display. The metal plates simulate the Earth and the sky. Their intersection is the simulated horizon, which must be located and locked onto by the horizon detector. Test results are registered and processed by the computers in real time. This next experiment tests the capability of the sun detector. Subsystems successfully passing their development tests move on to production. The new fabrication halls, clean rooms. Dust and dirt are strictly kept out. Here, the satellite's electronic subassemblies are produced. Each component is very carefully selected, even in terms of its raw material. Every component is accompanied by a detailed route card and history chart. The quality assurance team takes part in every step of the process. 100% success is the required minimum. These carefully screened and qualified components are the building stones of the satellite systems and subsystems. This is the satellite's computer, based on microprocessors, a revolution in space technology conception. In spite of its low weight, half of that of a conventional space computer, it perfectly performs all of its tasks. More tests. The thermal vacuum chambers where the satellite and its subsystems are tested for their ability to perform in space conditions. Another part of the production hall. Here, thermal blankets are produced. Their purpose is to keep the satellite systems in an envelope of predetermined temperatures, despite the extreme variations of temperatures in space. Each subsystem is fit with specially tailored garments. The ground control station. The antenna is already scanning the skies. Signals transmitted from Opek 1 are now received and passed on to the nerve center, the command and control center. From here, daily communication with the satellite is performed. Its path is tracked, systems are checked, and data is received. Launching of Amos-1, the communication satellite, is planned for the beginning of the next decade. From its location in space, Amos will be able to receive and transmit in high quality to every location in Israel, regardless of topographic conditions. Its operation will be a stepping stone, perhaps even a revolution, in Israeli communications. TV and cable transmissions, about to start operating in the next decade, will be directed towards Amos, transmitting a wide variety of broadcasts directly to our living room. Today's antennas will be replaced by small dishes, which will be smaller and much cheaper. Large industrial concerns, television stations, or the private customers hiring satellite services will be benefited by a private communications network. All telephone calls, telex, facsimile, and computer data transfer for every member of the network throughout the entire country will be carried out discreetly, efficiently, with no extra charge. Where personal, movable communications are concerned, Amos will enable reception of telephone calls, telex, fax, and computer data to every person, wherever he might be, through miniature portable communication devices.
So I would conclude that the trends that are going in the space industries from one side and the infrastructure that exists here in the electronic division give us excellent opportunity for business in the future. In the civilian areas, I believe that we can cooperate with many industries in the world, with Europe, with the United States, even with our neighbor. Why should we not take this opportunity to collaborate together and build some peace program? And it is available.
The capability of a nation to independently define, initiate, and provide for its own utilization of space is a national asset. The successful launch of Opek 1 proves once again that the Israeli space program is a technological breakthrough for the Israeli industry and provides a giant step towards the 21st century. Working together, IAI, Israeli Academic Research Institutions, and ISI, the Israel Space Agency, are already conceiving future projects enabling additional technological breakthroughs. Whatever the future may bring, one fact is already clear. We are on the map, or should we say, above it.